Hello and welcome to this review video. I'm Hannah. I already graduated from University of Toronto and would love to walk you through some of the key concepts that will definitely help you to have a better understanding of what you're studying right now in the course. So I've divided the different concepts that are covered in the lecture into different sections, and let's just dive in. I hope you enjoy. So the first sections, we're going to talk about the types of research claims and different types of validities. So we have different types of claims. The first one is frequency, which means how often something occurs or like how common something is. Like for example, like if I say 60% of teens use social media daily, that would be a frequency claim. So it's just about how often we have something in our research or in daily life or in any other setting. The second type is association claim, which means what is the relation between different variables. So this is not about a single variable, it's about more than one variable. For example, more sleep is linked to better memory. So it can be two or even more variables that have different kinds of relationship together, and we call this an association claim. Last but not least, we have causal claims, which, as the name implies, it's cause and effect relationship. So, for example, caffeine causes increased anxiety. Causal claims usually have very direct language on like something causing the other thing, so it's not really hard to understand which type of claim we're working with. Now let's move to different types of validities. The first one is the construct validity, which means are we really measuring what we want to measure? So like let's say my research is measuring quality of sleep. Am I really measuring the quality of sleep or am I actually measuring some different type of variable? That's what we call construct validity. So actually it is thinking about how well your operational definition matches the idea or like the conceptual definition. So conceptual definition is the definition that you have. For example, let's say sleeping well. Operational definition, it's how you actually measure and conceptualize that thing. So it's actually how you use that concept in your own research or in your own study. So there are different types of measurements that we can use in studies: self-report, behavioral, observational, and physiological, which I think is pretty simple to understand what is the difference of each. The next one is internal validity. So internal validity actually focuses on the variables and it asks, can you actually conclude that one variable caused the other? So you need to check if, for example, you have random assignment, what is your control group? So it's more focusing on the study itself and whether we can make conclusions on different variables. The next type of validity is external validity, which means can we actually generalize what we got from our study to other studies or to other settings? So let's say we have a study that was completely done in lab and we're not really sure if it can be applied into real life. That would be a threat to external validity. Let's go back to the sleep example. Like if I've measured the quality of sleep in a lab that is very, very controlled and like participants have no options on when to sleep and how to sleep, then my external validity would not be that strong. Like maybe sleeping at home is very different from sleeping at lab. So external validity is very, very important because it can have very serious consequences. Like, for example, let's say we see lots of problems with external validity in the news. Like, they may generalize the results of one study to the real world setting, which is actually not true. And it's very important for you to understand the difference between the internal and external validity because it can definitely be one of the questions on the test. And more important than that, it can be very important for your own studies. Like, we see lots of misinformation in social media and news nowadays, and lots of them stems from the fact that like science communication is very important, and lots of people are ignoring the difference between internal and external validity and how they actually are implied in real life. So moving forward, let's talk a little bit about different types of external validity. we have population validity, ecological validity, and temporal validity. I will just touch really quickly on each of them. So population validity is actually like whether we can generalize the studies to the general population or how our study sample was designed. So like we may have non-representative samples, which means like let's say we only have college students and now we want to talk about the whole population. And we also have different biases in the study itself. So for example, there's another thread called volunteer bias, which means participants who sign up might differ from those who don't. Ecological validity or ecological generalizability, it's actually talking about whether the results can be applied to different settings or environment. So my example with lab and with home was kind of ecological validity. And then last but not least, we have the temporal generalizability or temporal validity, which means can we apply the results at different times? Like for example, let's say we have a study done in 2010 on social media, which is different from a study done in 2025 because people are using social media differently nowadays. So rapid changes or like historical or cultural shift can be a very serious threat to external validity. And then we have a statistical validity, which we're going to talk more about. So it's more focused on the numbers and whether the statistical conclusions are accurate. We may look at the effect size, sample size, p-values, and confidence intervals, which we're going to talk about more later in this review. So now let's talk a little bit more about the variables, measurements, and different types of reliability that we have. So first of all, we need to clarify some of the terms we have: constructs, variables, and operationalization. So construct itself, it's something very abstract. Let's say happiness, let's say anxiety, or even let's say like quality of sleep. So constructs are usually the perceptions that we have of different things, and they are abstract, so they're not scientifically well defined. Variable is a measurable form of that construct. So let's say you measure anxiety with levels of different hormones in your blood, or even with your facial expressions. So it's actually something that we can measure, and it's different construct. So operational definition tell us how we're going to measure that construct. Maybe through a survey, maybe through a task. So how the variable itself is actually measured. There are two different types of research, qualitative and quantitative. I think that's something very clear. So qualitative kind of research is more descriptive, is more open-ended, it's very rich in details, like you can have interviews with people and you can just let the study flow. Quantitative one, it's more focusing on numbers and hypotheses. So it's important to know the difference of these two terms. And now let's move forward to scales of measurement. So we have 4 different types. Nominal, it just focuses on categories, for example, gender. So we have different categories for gender and like they're actually not number or they're not on a scale, they're just different categories. Ordinal, it's ranked, but there are no equal intervals. So the interval or difference between different ranks doesn't mean anything. So like let's say the race placements. Intervals actually focus on equal types of differences that are available between the orders or the equal intervals, and there is no true zero. For example, let's say temperature. So we know the difference between each degree of Celsius or Fahrenheit means something. And then last but not least, we have ratio, which we have the equal intervals, but we also have a true zero. So for example, the reaction time. And now focusing on different types of reliability. So please make sure that you actually go through different types of reliability and validity. That's very important. And you don't want to mix validity and reliability together. So we have 3 different types of reliability. The inter-rater reliability, which is the consistency across the observers. The test-retest reliability, which is the stability over time. And then the internal reliability, which means are the items on a scale actually consistent? So the inter-rater reliability more focuses on whether different observers have the same view on something. The test-retest reliability focuses on whether taking a test over time is actually stable. So like let's say you take a personality test and 2 years after this, the personality test turns out to be the same. That means the test has a very good test-retest reliability. And then internal reliability is actually the consistency we have among different items of a test. Now let's move forward to measurement quality and different validity types. So measurement validity has some different types. The first type is the face validity, which means it looks like it's measuring what it should. The content validity means that does it actually cover all different aspects of the construct? And then the criterion validity has three different factors. The first one is concurrent, which means it actually correlates with established measure now. The predictive is actually whether it predicts the future outcome. And then the known groups asks that can it distinguish between groups that should score differently? So we know for a matter of fact that there are two different groups, and we want to make sure that our test or our scale is actually distinguishing between these different groups. Convergent validity means that it should correlate with the similar constructs that are available. And then discriminant validity is just the opposite. It means that it should not correlate with unrelated constructs. Now let's move forward to factor analysis and dimensionality. So factor analysis is a statistical method that shows us if items group into factors, helping us know if a construct is actually unidimensional or multidimensional. So different factors or different items may actually cluster into same dimensions or may not cluster into same dimensions. So for example, let's say depression. Depression may have sadness, fatigue, hopelessness. So all different aspects of depression should go under one umbrella. This means that depression is a multidimensional construct. And we want to make sure that all different things related to depression are actually moving into one cluster. Now let's move forward to our next section, which is sampling and external validity. So we were talking more about the study design itself so far, but sampling focuses on whether we're recruiting our participants correctly and what is our method. So there are thousands of different methods for sampling, but we're going to cover just a few of them here. Just make sure to understand the difference between each. So let's first move forward with the probability sampling. So probability sampling have three different types: simple random, stratified, and cluster sampling. So simple random means that every person has an equal chance. We don't have any criteria. We just have different people all in one pool and we're taking out of that pool. Stratified sampling means that we have some demographic categories, for example, age, gender, income. There are thousands of different ways that we can have categories based on demography, ethnicity, race, gender, income status, all these kind of things. And then we can have some sort of stratified sampling. Cluster sampling is randomly selecting groups and not individuals. So this is different from the simple random. In the simple random, every person has an equal chance, but in cluster sampling, each cluster or each group has an equal chance. Now probability sampling. So we have four different types. Convenience means whatever is easy to get, like very easy to recruit. Let's say I'm living very close to a college and then I think, oh my God, maybe college students are the best sort of group to recruit and I'm going to take them. That's called convenience. Purposive is actually chosen based on criteria. So like, let's say I'm looking for individuals who have an income from some number to another number. That's like purposive. So snowball sampling, it's like participants recruiting others. So we are relying on a network of different individuals reaching out to their own networks. And then last but not least is coda, which means we fill up groups, but not randomly. So we're just focusing on some sort of demographic. So the difference with stratified sampling is that in stratified sampling, we have some categories, but we are still trying to have random sampling. Like let's say, we're looking into females, but still we're choosing randomly between females. The coda thing, it's more like I want thousands of females and thousands of males. So it's not random. So there are different threats to external validity. The first one is non-response bias, which means when people who don't respond differ from those who do. So, like, let's say we have a survey, and the ones who are taking the survey are the ones who are more outgoing and are more interested in taking part in different studies. That would provide some sort of non-response bias. Sampling bias, it's when our sample doesn't reflect the population. This is a very, very common bias. So, like, let's say just focusing on college students and not talking about people who never had access to education, it's some sort of sampling bias. Of course, it's completely fine to just focus on one group of people, but it's very important not to generalize that to the whole population. So, for example, let's say generalizing the studies which are done in North America and Europe to the whole world. Like, let's say we have a sample of North Americans and we're studying their sleep patterns. And then when you read different journals, you see that it's talking about all men sleep less 2 hours in comparison to 2010. That's some sort of sampling bias, and that's some sort of threat to external validity because we just focus on, like, for example, North Americans. We didn't focus on Asians. We didn't focus on, like, I mean, people living in the Asia continent. Or, like, we didn't focus on different countries. So that's some sort of sampling bias, and that's a threat to external validity. And last but not least, we have some situational or temporal factors, which means the time or the setting of the study affects how generalizable our results are. Now let's move forward with the descriptive stats and inferences. So this is actually more about the data we have and not the study design itself. So after getting the data, let's say we have a quantitative study, we may have different measurements on our data itself, and we're going to focus on them in this section. So first of all, we have some descriptive statistics, which these are the ones which describe and summarize data from a sample or population. It's like giving you a snapshot from your data. So first of all, let's talk about the central tendency, which tells you where the center of the data is. So we have mean, median, and mode, which is important for you to know the differences. The mean is the average, which means you just add all values and then divide them by the number of values. The median is actually the median value when numbers are in order, so the one in the middle. And this is not very sensitive to the outliers. So outliers are the ones which are different from the general data points that we have, and median is not really that sensitive to outliers. So when you have lots of outliers, it's better to use median, not the mean, because mean is highly affected by the outliers. And then the mode is the most frequently occurring value in your data. For example, let's say you have lots of 10 in your data, and 10 is going to be your mode. Now let's talk more about spread, which means how, as the word says, spread your data is. Tells you like how spread out or clustered the data is, and let's first start with variance. So variance actually measures the average squared difference from the mean. I'm going to repeat that because it's so important. Variance measures the average squared difference from the mean. So the more variance you have, the more data points are spread out. And then the next one is standard deviation, which is the square root of the variance. It tells you how much values typically differ from the mean in original units. So the difference we have between variance and the standard deviation is that the standard deviation has some original units based on how different your data is from the mean, but variance is just telling you how spread out or clustered it is. And then skewness, which tells you the asymmetry of the distribution. If you have a positive skew, it means that the tail is to the right, so you have lots of lower values and a few very high ones. The negative skew is tail to the left, which means lots of higher values and a few very low ones. And then next, let's talk about the inferential statistics, which it can help you make some educated guess about a population based on a sample. It actually goes how, like, we go from data to some conclusions. So point estimate is the best guess of a population parameter based on the sample. So sample mean itself can be a point estimate of the population mean, but it's very important to be careful with making these kind of generalizations. Margin of error focuses on the range of accuracy that we have. So it's actually the range of like the uncertainty you have around your point estimate. So like if your estimate is 70% plus minus 5%, then the margin of error is 5%. The larger the sample is, the smaller the margin of error is. So we have more precise estimates when you have smaller margin of error or when you have a larger sample. Confidence interval is a range you're fairly certain that actually contains the true population value. So let's say you have a 95% confidence interval, which is usually the number the researchers use, which means if we repeat the study 100 times, 95 of those intervals would actually include the true value. So we don't have the true value, we're just making some educated guess. The wider confidence interval will give you more confidence, but less precision because it means that the true score can be in any point of this window. The narrower confidence interval would have more precision but less confidence. And now let's move forward to larger sample means smaller margin of error, which we actually covered. And then we also talked about confidence versus precision trade-off. So I think, yeah, we can move forward to the next part. So here in this part, I actually designed some few sample questions, which is pretty easy to understand and go through. But of course, I would definitely recommend you going through the slides yourself and trying to design some questions for yourself as well. So the first question is asking which is a causal claim. This is actually a very easy question because as I covered before, causal claims usually have a very direct language and you can easily understand that like the option that include the word causes is the true answer. So please make sure that you know that correlation is not causation. I think that's a very, very famous first sentence that any student knows. Make sure that you just choose the option that include the word cause. So the first option A, it just reports a percent and it's not about the cause. And options B and D are associated or correlated, they're not caused. Next question asks, measuring anxiety via how anxious are you is a self-report because it's asking the participant themselves about how they feel about it and they're reporting. So physiological measure focuses on like physiological parameters, behavioral measure focuses on the behavior of participants, and observational measure means that you don't manipulate anything in the study setting, you just sit and watch. But as we can see in this question, this is like a self-report. The person is answering themselves and we're asking the participant directly. So the next question asks, what does construct validity actually assess? So construct validity, as we covered during this review, it assesses whether the measure reflects the construct and are we actually measuring what we think we are. So as we actually covered before, number A is like the sampling, like whether the sample was random. So that's more talking about the sampling bias or like the sampling methods. Number C, whether the results are generalizable. This actually focuses on external validity because it's talking about whether we can generalize the results to the general population or to the other settings. And number D is like whether the study is ethical. That's a different concern and it's not related to the construct validity. Number 4 asks about which is not a type of reliability. So it's very important for you to know the difference between reliability and validity. Please focus on that. This is actually a very easy question. So we know that inter-rater reliability actually focuses on whether different raters agree. Test-retest reliability focuses on whether our test is consistent over time. And internal reliability focuses on whether items in one test are consistent. So now let's move forward to the next question. Question number 5. When different methods of measuring the same construct correlate, this is convergent validity because, as we covered before, we want to make sure that the factors that are related to each other are actually showing some sort of correlation in our test. So discriminant validity focuses on different things that don't correlate. Concurrent validity focuses on things that are measured at the same time, often for the outcomes. And the correct answer is number C. Question number 6. A sampling method where you recruit based on availability is the convenience. So we had the example of college students and living close to a college. Convenience sampling method is just recruiting based on whatever it's easier for you. And to review again, the simple random is when everyone has equal chance. The stratified is when you have groups like age or gender that are proportionally sampled. And then the snowball method was when you ask the participants to recruit each other's and you are using the network that each participant has. Question number 7 asks, which is an example of a ratio scale, which is number C, number of correct answers. So the ratio scale is the one that has a true zero and equal intervals. So you can actually say like twice as many. So GPA doesn't have any true zero, like the zero means nothing. Temperature in Celsius. So zero actually isn't the absence of temperature, so we can't choose this one. And for the eye color is actually some sort of categorical value. So the right answer is number C. Question number 8 is pretty easy. So it's asking what is Chromebox alpha test, which you know it's about internal reliability. So it's focusing on whether the items on a test measure the same thing. And so the predictive validity focuses on whether our tests predict something. Sample size is not related, and the factor structure is the factor analysis that we covered before. Question number 9. Which reduces internal validity? So confounding variable. Confounding variable are the extra variable that are kind of messing things up, making it very unclear what caused what. So it's like a third or like fourth or some extra variable coming in, which we are not considering, and that's a confounding variable, which can be a threat to the internal validity. A random assignment actually helps internal validity, and number C, which is operational definition, and number D, which is blinding, help us with clarity and control, but they are not really related that much to the internal validity, and they're not a threat to it as much as confounding variable. Question number 10. What type of claim is teens who sleep less are more anxious? So this kind of association, because it says two things are related to each other, it's not talking about causing each other. So if we want to make a causal claim, we would say sleep causes anxiety. Frequency is about the number of things that occur. For example, let's say 20% of teens who sleep less are more anxious. And then construct is just type of validity, it's not type of claim. So what is an example of content validity? So the first one is the correct one. A stress scale only asks about physical symptoms. So when we don't have content validity, it means that some important parts are missing. Number B is correlation. It's about criterion validity. Number C is like about reliability, not about the content. And then number D is about prediction. So it's the predictive validity that we have. So like, let's say a scale predicts depression over 5 years later. This is predicting the future, and it's not focused on content validity. Question number 12. What kind of skew is distribution with most score low, tail to the right? So that's positive skew, which means the tail is to the right side. Number A, negative, tail is going to be on left. Symmetrical, we don't have any skew. It's not skewed to any side. And then inverted, it's really not a real term in statistics. It's just like a trap choice. Question number 13. Which method is best for identifying causality? So the best method we have is experimenting it, which means having some control variables, having some other variables that we're changing. So number A, B, and D can show relationships. They can show us causality. So case studies, surveys, and correlation studies are just showing us associations or the relations that variables have, not which is causing what. So the next one, like what is experimental realism? It's actually whether we engage the participants genuinely and whether they feel the experience feels real. And the other options are all wrong and they're not related to realism. Question number 15 is asking when participants act differently because they know they're being watched, what kind of problems we have. So number A and C, demand characteristics and reactivity. So something important to know is that observer bias mostly focuses on the researcher itself and not on the participants. The demand characteristics is actually when participants know what the researcher is looking for and they're trying to some sort of meet that criteria or like actually please the researcher. Reactivity is focusing on whether the behavior is changing because they know they're being observed. Test retest error is not related here, and observer bias, as I said, is more related to the researcher themselves. So option A and C can be both correct. Question number 16. Which of the following is a known groups approach? So the correct answer is number A, comparing depression scores of diagnosed versus non-diagnosed individuals. So as we covered before, known groups are when we have existing categories and we want to use them to see if our measure can detect the difference in similarities. What is a risk of behavioral tasks? So a risk that some behavioral tasks can have is the ceiling or floor effects, which means everyone is scoring too high, which is the ceiling, or scoring too low, which is the floor. So in this question, it's kind of a little bit hard to understand which is the right answer because all of them can be true in some sorts, but it's important to prioritize the one that is mostly related. Number C is usually the main threat that we have to behavioral tests. A p-value less than 0.05 means that the results are statistically significant. So it's important for you to know this term. When we have p-value less than 0.05, it means that it's not likely to have the results due to pure chance. And it means that we have a statistical significant result or data point. So the p-value doesn't have to do anything with the randomness of the sample. And it also doesn't have to do anything with the effect itself. We just know that our results are now statistically significant or reliable. We don't know that whether the effect is strong or not. And then number A, so when we have small p score or p-value, it actually means that we can reject the null hypothesis, or like it's more probable to reject the null hypothesis. It doesn't mean that the null is true. Question number 19. A large sample size affects margin of error. So we talked about this before, that the larger sample we have, the smaller error is, and it's more precise. So actually a larger sample size can help you with generalizing the results or the external validity, but that's not the main effect. The main effect here is the margin of error. And the face validity and skewness are not really related. The last question we have here, a correlation R equals to minus 0.76 means that we have a strong negative relationship. So the closer the value is to minus 1 or to the 1, it means that it's stronger. So it's important for you to know that just because a number is negative, it doesn't mean that we have a smaller correlation. We should actually just focus on whether they are close to 1 or minus 1. So as one of the factors is going up, the other one is going down. This is kind of like a strong negative relationship. So please focus on the fact that the strongness or weakness of correlation doesn't have to do anything with like positive or negative sign. It's more have to do with being close to positive 1 or minus 1. Actually, I hope this review was helpful to you. I tried my best to cover some of the content that it may be helpful for your review and for your test. And this is one of the best courses I actually took during my undergrad. Hope you have a great time and you got this.